There's nothing wrong with calculating a deviation to show how far below the mean or above the mean a certain individual is. However, if you're in a situation in which you've recorded the data values of two people, and you want to decide which of the two people has the more extreme data value, then the deviations of the two people are only useful if the two people came from the same population. I'll spend some time explaining what I mean by that. Let's imagine that you're in a situation in which you recorded the data values of two people, and you want to decide which person has the more extreme data value. If the two people came from the same population, then the deviations of the two people would tell you which person is more extreme. When two people are members of the same population, deciding which person is more extreme is actually pretty simple. The person with the smaller deviation is less extreme because that person is closer to the mean of the population, and the person with the larger deviation is more extreme because that person is further away from the mean of the population. Here's an example. If the mean exam score of a certain class is 75, a student in that class with an exam score of 80 has a deviation of plus 5 because that student is 5 above the mean, and a student in the class with an exam score of 85 has a deviation of plus 10 because that student is 10 above the mean of the class. The student with the exam score of 85 and the deviation of plus 10 is more extreme because that student's exam score is further from the mean of the class. Unfortunately, when two people come from different populations, deciding which person is more extreme isn't so simple. When two people are members of different populations, the deviations of the two people won't tell you which person is more extreme. I think that point will make more sense after I share an example. Let's pretend that two different classes have both taken the same exam. Both classes have a mean exam score of 75. In the first class, almost all of the students are in the 70s. In other words, in the first class, almost all of the students have exam scores that are pretty close to the mean. In the first class, the exam scores have pretty low dispersion. However, in the second class, the students' exam scores are spread out across a much wider range. In the second class, the exam scores have much more dispersion. In the second class, there are several students in the 50s, 60s, 70s, 80s, and 90s. If you think about it, a student in the first class who has an exam score of 80 is actually pretty extreme. In the first class, almost everyone is in the 70s, so a student with an exam score of 80 is at the top of the class. It's true that this student is only 5 above the mean, with a deviation of plus 5, but the student is pretty extreme because he or she is further away from the mean than most of the other students in the class. Also, if you think about it, a student in the second class who has an exam score of 85 actually isn't very extreme. It's true that that student is 10 above the mean, with a deviation of plus 10, but that student's exam score isn't very extreme, simply because there are quite a few other students in the class who are even further away from the mean than that student. Let's now think about which of those two students has the more extreme exam score. The first student, with the exam score of 80 and the deviation of plus 5, is actually more extreme than the student with the exam score of 85 and the deviation of plus 10. That's because the student with the exam score of 80 was at the top of his or her class, while the student with the exam score of 85 had quite a few students above that student in his or her class. Basically, when two people come from different populations, the person who is more extreme isn't necessarily the person who is further away from average. The more extreme person is the person with fewer other population members beyond them. That's why the deviations of the two people don't tell you which person is more extreme when the two people come from different populations. It turns out that there is a value that can be used to decide which of two people is more extreme when the two people come from different populations. That value is called a z-score. Unlike a deviation, a z-score doesn't simply show how far below the mean or above the mean a certain data value is. Instead, a z-score shows the number of standard deviations that a data value falls below or above the mean. If one person has a larger z-score and another person has a smaller z-score, we'll automatically know that the person with the larger z-score is more extreme, even if the two people came from different populations. That's why a z-score is useful. For example, if we calculated the z-score of the student who had the exam score of 80 in the first class, and we calculated the z-score of the student who had the exam score of 85 in the second class, the student who had the exam score of 80 would actually have the larger z-score. That student would have the larger z-score because that student's exam score was actually more extreme.